had an audit where they put the blower door on your front door, and they check you for how much airflow you've got, leakage. They said your leakage is quite good, or not very much leakage, so that sealing was not going to be something that we particularly needed to do. Part of the reason for that is the place is all sheathed in 4x8 sheets of, I think it's OSB. It's either that or plywood, not sure. But anyhow, there's very few joints in that. And apparently they had put the windows on pretty well. But they said, your air conditioner isn't the greatest. So that was the thing to look at for a replacement. At that time, there were not the cold climate heat pumps that are currently available. They were, as I joked, they were the cold draft specials, because I'd had some people who had them. But anyhow, so we started looking, talked to some people at work. One of them had a ground source heat pump. What that does is it takes water from the ground. I already had a well on the property, so that existed, and then runs it through the thing, takes the either heat or cool from it, depending upon whether it's summer or winter, because that water down there in the ground is about 55 year round, varies a little bit. And then in order to do that, had to have a second well installed. And they, talking to the well driller, he put what's called extra slit pipe, which is where the water goes back into the ground. He said he wanted to make sure there was plenty of places for it to go back into the sand. Now, down here where we are, it's all sand. I don't know, I believe a lot of you are up maybe in northern Jersey, where you may have a lot more stone stuff. Doing a well probably be a lot more expensive up there. So anyhow, the AC died shortly thereafter. Got a few quotes and purchased a Bryant carrier unit. It's funny, the unit comes and you get two labels. You can put on either the Bryant one or the carrier. Same piece of hardware. It just, which brand you like better. Also, to supply it, we had to replace the well pump with it's a Grundfos variable speed pump in the existing well. So what that does is, if you are running the geothermal and taking a shower at the same time, it will up the speed on the pump, so that the pump doesn't keep cycling on and off. If you on a well system, normally the way it would handle pressure is, it takes it up to the 60 pounds, then it shuts off, waits till it drops to about 40, then it kicks on again. With the Grundfos, it's a variable speed. And when we did this, the gas bill went from hundreds each month in the winter to about 40 monthly all year round. The solar that we had put on continued to do about 2/3 of our annual usage, but it was now covering what had been the gas. The electrical supply around here, Steve is saying his is out at the moment. Well, my wife's kind of sensitive to heat, so unfortunately we have a natural gas generator where the yellow circle is. That's where the outside air conditioner used to be. Had to make the pad a little bigger, but it only runs when the grid dies. And about 4 years ago, decided to replace my 24-year-old dishwasher. I'd been nursing along with 2 new pumps and a water valve. Should have replaced it a long time ago, as the new one's clean so much better and uses so much less water. Another thing that I did is after a big snowstorm a couple of years ago, I went out and got an electric snowblower, because I've got like 100 foot of driveway, and when you get a foot of nice wet South Jersey snow, you want a snowblower. This past winter, I think it got used 3 times. Some winters it doesn't even get used because we don't get any snow. Also, in going to electric, this past Christmas, we ordered a electric stove to replace our 27-year-old gas stove. And in that, we found that, hey, the stove was not the big expense. The big expense was getting the electric line put in from the panel in the basement. Plus, since we have the generator, we had to have it's essentially a time delay that's put in there that if the electricity goes out, it cuts off the stove until the generators had a chance to fire up and run for a while, and then it will let the stove back on. And then we also had to get the plumber in to cap off the gas line because the way it was sitting behind the existing stove, we couldn't get it to within like 2 inches of the walls. That was not good. At this point, I'm down to 3 gas appliances. One of them is my 33-year-old dryer, which we brought with us from Maryland when we moved up here. Had to replace the timer mechanism in it. Not the clock part of it went, but one of the contacts went many years ago. Also still got a gas hot water heater. When that one dies, we'll be looking at probably one of the heat pump hot water heaters. And also have a gas fireplace, which doesn't require any electricity for emergency heat if the geothermal fails in the winter. And I'm looking for a plug-in minivan to replace there. I think it's 14-year-old Sienna, but it's only got 85,000 miles on it at this point, so it's still young. But nobody makes one of those yet, so we'll keep waiting. Recently had to have the roof replaced because unfortunately along this eastern edge, we were getting leakage where they had installed the panels on the roof. The roof didn't owe us anything, but it was unfortunate that it was starting to leak there. And at that time of doing that, I said, okay, this is a 10 kW. It's doing approximately 2/3 of everything. I'd like to add on a 5 kW. That is the picture on the left, which is the new 15 panels. The original set takes 46 panels, but the new panels are so much higher wattage that we use much fewer panels. Plus the new ones have got an individual inverter underneath each one. And so if you get shading on one of the panels, okay, well, that's unfortunate. You know, that panel's not going to be generating as much, but it doesn't shut down the whole string like it would with the original. And one of the other things is somebody's probably going to ask, why have you got this big area here on your roof? Well, there's this nice little chimney here, which when they took this picture, it was only putting out this little teeny bit of shade. You get to midwinter and that shade stretches all the way over to the edge of these panels. That's why that section is not used. That's why we had to go. Although array number 1 and array number 4 are the only 2 that really face south, and those are actually my best ones. Thank you.
Wow.
John, there's one question for you.
Sure.
When you say the big expense for the stove was running the electrical line, can you give us a ballpark?
Yes. The stove, as I recall, was about 800 because the wife wanted white. You could have gotten it for less if you wanted stainless, but white matched everything. And the line ended up being twice that. So it was like 1,600 because for one thing, had to have the time delay plus the running the wiring from essentially one end of the house to the other because the panel is at one end and the stove is at the other. So.
Okay. There was another question for while we are on stoves. A question for Phyllis.
Yeah,
Anybody? Here we go. It disappeared. Uh, Thanks for sharing your experience with your path to electrification, Phyllis. Can you mention the make of your heat pump and electric car?
I'm sorry.
Yeah,
I didn't get that. I was trying to unmute.
I think you mentioned Bryant Christ. Well, the make of the heat pump. Who made the heat pump, and who makes your electric car?
Electric car? I have a
Yes,
Tesla.
a Tesla. Okay.
One of the Tesla 3s.
And there was another question for you. Discuss the benefit of your electric stove. Is the stove induction?
Oh, there are several. One thing, it heats very evenly, and I like that. But I do not have that much counter space in my kitchen, and that adds counter space. When I'm not cooking on it, I can use that for anything because it's just black glass. So that's another benefit of the electric stove. But we got all electrical appliances basically because we wanted to be as electrified as we possibly could.
Okay. Thank
I
you
don't
very
know if
much.
I answered the question or not, but
If there's more questions, people should add the questions to chat. I wanted to make sure we have enough time for Hap Haven. Hap is the professional of our whole group. So where are we? I'm hold on for a second. I'm trying to figure out.
There we go.
Here we go. Okay, so Hap, you can start sharing your.
So you've got.
Yeah, so maybe you could just introduce yourself. I'm lost where my notes are, so
That's right. I
Go
will
ahead.
definitely do that. So as soon as I get this thing to, there we go. So if the people online don't know me, my name is Hap Haven. I'm an outreach manager for New Jersey Clean Energy Program. And normally I'm working with new construction, but tonight I'm going to tell you a little bit about my house. And this is my house. It's a labor of love for many, many years. And I want to say that we are an all electric house almost. And then I have a wood burning stove, an 80,000 BTU Vermont Castings wood burning stove that has a catalytic converter. So it's a very high efficient unit. And I use that on the coldest days of the year. But I want to give you some information about the house here. Numbers, not just pretty pictures, but numbers. I'm going to give you them in 10-year intervals. I've lived in the house for over 30 years, so you can just multiply everything times 3 or 3.5. I've saved about $27,000 over the average house, and this is how I've done it. The average house in the Mid-Atlantic region, okay, uses about 31,000 kilowatt hours per year for a 2,000 square foot house. My house uses 21,000 BTUs for a 3,000 square foot house. If you do the math, and I know Steve's going to get and do that math. Basically what I'm doing is I'm saving 17,000 kilowatt hours over the average house every year. Multiply that times 10 years is 170,000 kilowatt hours. If you have electricity at 16 cents a kilowatt hour, that's a savings of 27,000. So the question is, how did I do that? I want to say that I'm going to broaden the sort of the conversation here a little bit in terms, not talk just about energy, but talk about carbon. Because when Steve talks about zero energy homes, we're also talking about zero carbon homes. We're talking about sustainability, and carbon is an issue across everything you do in your house, not just how you heat it or cool it, right? And so what I went to do is basically use as many recycled and salvaged materials as possible in my house, buy all the non-toxic products I could for the house, design the house to take advantage of the site and the sun. This is really important for a passive solar house, which is what I have. Okay, and then buy the most energy efficient appliances I could afford. So it's always about the site, the sun, and the shell of the house first. And then we put in the most energy efficient appliances we can. And then we do solar on top of that. Now, I sold solar for a while, installed solar electric systems back in, it was in the 2000s. And I sold a lot of solar systems to people who had leaky houses that were poorly insulated. And that's because they wanted solar. Okay. And the first people that I sold houses to used it as bragging rights for their martini parties. Right. And I didn't care. Right. Because when you put solar on a house, you automatically will save, normally the national average is about 20% on your usage, because every solar system that's installed has this is what you're using and this is what you're producing. And so those two things side by side, as a homeowner, you get to see, oh, wait a minute. I'm using more than I thought I was going to use. And so you sort of have a net effect of saving. Anyway, here's where I started in 1986. It was a stone carriage house that was a gut rehab, and I brought it along to look like this nowadays. And you can see that on the left-hand side, that archway, that entire facade is now inside a solar hallway. This is the southwest facing site or side of the house. And I wanted to utilize the solar mass in that wall. That's an 18-inch stone wall. I wanted to be able to save that. So it's not just about buying high efficiency things. It's about understanding how a house can work, okay, and may fail as well. So, let's look at it here. Of all the things in my house, it's like I tried to recycle as much as I could. So about 80% of my tool shed was salvaged. About 70% of all the materials in the yard was salvaged, and about 60% of all the materials inside the house, okay, were salvaged. And this includes the trim, of the house. These are all recycled. The one on the left is from the carriage house. The one on the right is from a house not nearby me, and the one on the right, or that one in the center, was actually a kitchen cabinet. The one on the right came out of an apartment building that had a fire, and they threw those doors away. And all I did was refitted them with, and maybe you can guess, this was the top of a Victorian mirror that was getting tossed. So I added that with heavy duty moldings and created a door. So every time I'm reusing something, okay, I am saving the energy and the time that it took to make it, the raw material, as well as the transportation to get it to the site. A lot of carbon, a lot of embedded carbon in that, a lot of energy in that. This applies for the landscape as well. The left-hand picture is back in 1987, where this is a friend of mine was helping me plant these black locust trees. The one on the right is the current day, what those black locusts look like. Now, this tree here, this black locust here, used to be right here. And I took that down, and I got myself 300 square feet of black locust decking that I could use. We actually cut it down, milled it on site, and I have it drying currently, and we'll go and use it for the decking, in the near future, hopefully next year. Okay, of all the plant material, hundreds of perennials I've salvaged, 55 shrubs, 23 trees. It's very easy to find plant material as well as building material. And recycled landscape can be beautiful too. You're looking at mostly recycled materials here. This white cloud crabapple tree came from the Philadelphia Flower Show like 30 years ago, right? And they were throwing things out at the time. Okay, it's just amazing what you can do. Okay, this is all looking at recycled landscape. This red bud was found in a field. This red bud tree, it's a native tree. Okay, and so it's like everything I'm doing is salvaging. Now here's the hardscaping. The picture there on the right is showing you all the hard things, the bricks, the stones, and things like that we saved and reused. And all the stuff we couldn't went to either clean fill or it went to road base. So nothing was sent off site that wasn't reused, and we kept everything else. Lately, I've been saving rubble on the site in cages in the backyard to reuse it, and we're going to be reusing it as the base for a chicken coop this year. Here are the numbers. Okay, about 2,000 square foot of hardscaping on the property. That's a fair amount of hardscaping. You know, we're talking about the driveway, the sidewalk, the patios, okay, and curbing, all recycled. We even recycled the tennis court behind the property. This is a tennis court, and you can see I've cut it into 16 by 24-inch blocks, and we've used that for curbing and also for pathways in the house. Again, there is carbon associated with the manufacture of that asphalt, you know, like 50 years ago. Not only was there the manufacturing process, but there was all the transportation and labor, and I've saved that instead of giving it to the dump. Water, I have 6 different storage or recycling systems on the property. The one on the right here is a pervious patio that I have in the backyard, meaning water drains through it and is collected and goes to my orchard, going to watering the orchard. The picture on the left is just a really fun way of capturing the water on the roof. Okay, and then it goes through the trellis system on the left there, goes to the rain barrel where I use it in the property, or if I have overflow, it goes into the dry stream bed. So the water on this roof, nothing goes off site. It's all stays on site for use with the plant material. I have not sent a scrap of food to the curb for over 30 years. Okay, this is called a green cone, and it is a composter for food scraps. Okay, and it is either a composter or digester, depending upon how full it is and what time of year it is. The difference between composting and digesting is anaerobic, without oxygen. Composting is with oxygen, and this goes back and forth depending upon the time of year. Let's look at the numbers. Okay, over 10 years, I've saved almost 2 tons of food going to the landfill. Okay, and you can do this tomorrow. This thing costs, I mean, when I bought it, it was like 80 bucks. That was 30 some years ago. It's probably $150 now. Okay, but you can buy it online and then never put any, buy it online and then never put another food scrap to the curb. Everything on site, I mean, inside the house is either recycled, products, or environmentally safe products like the Brazilian cherry floor in my dining room and kitchen. Okay, Brazilian cherry is with quotes. Okay, is actually eucalyptus. Okay, and eucalyptus is a sustainable resource, right? And it has a low VOC surface on it. Upstairs we have wall-to-wall carpeting, but we got used wall-to-wall carpeting. It was almost brand new plush carpeting out of a house where the new owners said to the contractor, "Get it out of here. We want a new color." It had only been in for like 2 years. It's a 30-year carpet. So we took it for free, paid a couple $100 to have it installed, okay, and had no VOCs associated with the carpet because it had already off-gassed in the house where it came from. All right, now we want to take advantage of the sun, right? So there's that outside of the house on the left. Okay, what we did was we regraded it, got more room for the patio and everything, and then we took that facade and we put it inside a solar hallway. There's the solar hallway, and you can see the sun shining through the windows in the wintertime up on the wall. Okay, this thermal mass, this very dense stone, mortar, and brick, and plus the concrete floor, holds the heat, okay, in the wintertime, but it also does something in the summertime. If I can cool the mass down at night using my whole house fan, then it can absorb heat from the house during the daytime, meaning that I don't have to air condition, not on every day. Okay, the picture on the left is an infrared picture of that same solar hallway, and you're looking at the hallway from the reverse angle. Okay, and you can see the sunlight shining in all the way on the wall, but in the summertime, the sun rises in the sky and creates a much different sun angle, and that is shading the windows. The large overhang is shading the windows. Again, what I'm showing you here is it's not just about high efficiency equipment. It's about the house, the site, the mass, okay, the air tightness, the level of insulation, then it's about the other stuff. So let's talk about the other stuff. Here's my solar water heater. It is evacuated tube collector. You can see it being installed on the left-hand side there. We have 15 evacuate tubes, like thermal tubes, that collect the heat and then transfer the heat to a manifold that's connected to the water heater on the right-hand side. Now, this, when it comes to solar thermal units, you can use antifreeze to prevent from freezing in the wintertime, or you can not do antifreeze, but do basically water only, and you get 20% more efficiency. But you have to have an antifreeze device which says, oh, the manifold up on the roof is getting cold. Let's circulate some of the hot water up there. And coming down the home stretch here, we got appliances. Last but not least, high efficiency washer and dryer, high efficiency refrigerator, high efficiency dishwasher. Okay, and the one thing everyone wants to know about, the high efficiency cooktop. Okay, this is our second induction cooktop. This is a Samsung. The first one was actually a Sears, and we bought it in the early 90s and had it until 2 years ago. And Sears at the time in Philadelphia was going out of business, and it was the 69th Street store, and it was the last day that they had things on sale. And I walked through it, and I came to the kitchen appliance section. Everything was cleaned out except there was an induction cooktop sitting there. It was their model, their show model. And I looked at it and I looked around and I said, people have no idea what this is. It was $100. And I said to the person, can I buy that? And they're like, yeah. I bought it, and it's like I had that thing for so long. And on the picture on the right, you can see the level of cooking, and you can see this dial here. See where my cursor is? All you do is put your finger on it, and you rotate to the right like a dial, and this number will go from 1 to 10. You can use a booster on this to go to 15 if you're trying to boil things really fast. It cooks just like gas, without any of the pollution from gas. When it comes to cooling in the house, okay, there is a hierarchy of cooling. Okay, first, shading if you can do it. Second, shading on the house if you can do it, like large overhangs, awnings, things like that. The next thing is a whole house fan, which you see mine in the lower left-hand corner. The last thing, okay, is your air conditioner, in my case, a Lennox, which I am now replacing. Okay, this has been my unit forever, and I'm replacing it with this unit. It's made by Chiltrix in Virginia. Okay, and it's not an air to air heat pump, it's an air to water heat pump. Okay, and that is everything, the evaporator. Remember Phyllis showed you the outdoor compressor and then the indoor evaporator? Well, with these units, they're together in this outdoor unit. And the beauty about that is that the amount of refrigerant is only about this much. It's a very small amount. It's factory sealed. So there's no leakage into the atmosphere, which is the hidden gorilla when it comes to heat pumps and air conditioners, is all of the refrigerant that's being lost into the atmosphere. And that's a whole nother story. But then it goes into the house using water. Okay, so I have a heated or chilled water line that goes inside to a buffer tank, and from there it's going to go to my radiators in the room. Now these things are called fan coils, but they're basically just a new style radiator with a fan that blows across the coil. So I get to use these in all my rooms. On the first floor, because of the way that the old ducting is, I'm going to use a central unit, but upstairs and in the lower level, I'm going to use these guys. So Steve, I know I've taken up way too much time here, but I really want to thank everyone for paying attention. You can contact me, okay, at Clear Result, which is where I work, okay, or you can check out my Instagram account where I post things about sustainability. Steve, I got through that, and you still have a little bit of time to spare. I will give this presentation as a PDF to Steve, and he can send it to all of you guys so you can get details But now I guess we're up to questions. You still there, Steve? His Wi-Fi dropped out. His battery in his car stopped working. Well, why don't we do this? Because Steve's not on the line, why don't we just unmute yourself and ask a question? It's like, if you have any questions for Phyllis, John, or myself, feel free to just, shout it out. I know Steve likes to end at like 1/4 so that gives us 6 minutes to answer any questions you might have. If you got to drop off, that's great. Thank you so much for your time. And again, I'll be sending this presentation to Steve so he can distribute it.
Question. So could you elaborate more a little bit on the solar hallway idea? So like why I feel like conventionally, you would just put make a large insulating wall on the exterior wall. Like why have that kind of gap and then the thick wall inside?
Right. Well, there's a number of ways that you can do this. If you have a non-mass wall, like a framed wall, doing what you're suggesting is it's called a trom wall. Basically, it's a solar collector attached to the side of the house. Okay, and it's vented to the outside during the summertime so it doesn't heat the house. And in the wintertime, the vents at the bottom and the vents at the top are open and you get hot air circulating to the house. That's great. But that doesn't do anything for your house in terms of holding heat. Okay, for later on. If you think about a passive solar house would be an adobe house in the Southwest, like in Arizona, right? Where it absorbs the sun during the day and that heat takes a long time to get through the mass, but then it re-radiates into the house at nighttime. This is that sort of concept, except we don't have the clear skies or the warm temperatures, in the wintertime. So what we want to do is bring the mass inside where it's insulated. And on 2 other walls where I had stone, I actually put exterior insulation before I put the stucco. In this case, I wanted to see this beautiful arch and the beautiful stone. So I brought it inside the hallway so I could see it and also get the benefits from it. Did that answer your question, Nathan?
Yeah, thank you.
Yeah, sure. Passive solar is something that was taught in the 70s, 80s, and 90s, and then sort of in architecture school, and then sort of fell out of fashion. There's a lot of books were written, about it. Nowadays, people talk about passive homes, which is basically building a house that is insulated well enough and airtight enough that you only need a tiny little bit, of heat to heat it and a tiny little bit of cooling to cooling. But when you get something that's that tight and that well insulated, you have to pay attention to humidity, because humidity can build up inside a house. And so you have ventilation systems that will take the humidity out and bring in fresh air. And I think most architects are moving toward a combination of the two, right? It's a passive house, styled house, a lot of insulation, very airtight, but then also has some thermal mass and solar exposure. Hey, Steve. Well, I've been taking Q&A without you, if that's okay. Oh, you're on mute. Tell Pat to unmute herself. He's also frozen. That's so funny. You have to hand it to Steve for actually making this presentation happen tonight, given he had no power and he had to drive to the top of the world to get his cell phone to work.
Hey, Hap.
Yes.
Hey, Mike Winke here. So great presentation. Fantastic. So do you think you could do this as affordable homes and sort of mass produce? Because all the stuff you did is great, but can you get it to the masses?
Well, I don't think we really need to, at least quite the way that I'm doing it, probably the way that Nathan was talking about. And that is, I know you're familiar with the New Jersey multifamily, no, the finance agency, it's the Housing Finance Agency.
Yep.
Right?
HFMA.
Yeah, that's right. And, they take anybody who is applying for a loan for affordable housing to the front of their line, and they give them lower interest rates if they have high efficiency things in the house, and they've been focused on passive house construction. So a whole lot of affordable housing is being built at a higher standard than anything else in New Jersey.
Oh.
So it's already happening on the affordable housing side. There's no doubt about it, and that's true in Pennsylvania as well. Steve, Steve was there for a half second. There you are. You're still on mute, Steve.
If there's time for one more question. Well, first of all, thanks to all the speakers for very interesting ideas. We've got one question for Hap. You're talking about this composter / digester.
Yes.
Will that take animal materials?
It will, but clearly bones don't break down. I can say that I'm not a vegetarian, but the rest of my family is. So the amount of meat that goes into mine is a very small amount. The like Thanksgiving turkey and the Christmas turkey and a few other random things, go in there. And when I clean it out, every couple of years, you clean it out and recycle it into compost piles. And the bones just, they don't go anywhere. so that's of no use.
Downside.
But Phyllis.
I just want to ask you, with the composting, do you have to use nitrogen or some mixture like that with it?
No, it's designed for you to just put food scraps in, right? And food scraps are nitrogen. What you don't have when you put food into the digester is the carbon, right? In a normal, compost pile, you do, a rough mixture of nitrogen and carbon, meaning browns and greens, right? And a whole lot of people out there are now not even bothering to turn it, because you can get a hot pile and aerate it using air tubes. And, composting has become quite a science. It's really exciting. But from this food, I'm going to call it a digester so to make it easier to understand. There are times during the year where there isn't enough air inside the unit and it goes anaerobic, which means without oxygen.
Right.
And at that time, it will smell. A compost pile that goes anaerobic smells too. And you know what that smells like when you've got too much nitrogen, too much water, and not enough oxygen, right?
Terrible.
It smells terrible. But the thing about this is that it's all enclosed. Okay. And like I said, I've had that one for more than 30 years. And
Do you use this as fertilizer?
kind of what?
Do you use the broken down food as fertilizer?
Yeah, absolutely. You don't have to clean out the digester very often, but when you do, I would take that, which has already been composted, a rough compost, and then I would put it on my regular compost piles, right? And then mix it in with the regular compost pile, which is yard waste.
Thank you.
Yeah, sure.
Question about the insulated tube heat hot water collector or solar water heater.
Yeah.
Does that overheat sometimes?
Well, the interesting thing about it is every solar collector, has the potential of overheating. That particular one, okay, is great because it's facing southeast, right? So I get all the morning sun, all the noonday sun, but in the summertime, after about 3 o'clock, when it's really hot, and it's like it's getting no sun anymore, just whatever heat's coming off the roof. And I'll tell you, about when we had that first heat wave in May, like the second or third week of May, right? That was me going to the cabinet and turning off the electric backup, the backup to the solar water heater, because I
Mhm.
don't need it during the summertime.
Uh-huh.
And in the wintertime, you use the electric backup because there's certainly a lot of cloudy days and you're not getting as much sun, right? So, but here's a quick tip for you. Now that heat pump water heaters, okay, have gotten past like the beta, like the last 10 years has been beta testing and manufacturing of heat pump water heaters. Now that we're into heat pump water heaters, that are very efficient and quiet, and we know how to deal with them in terms of the spaces they go in and where they vent and when they vent and all that sort of stuff. I wouldn't put my solar collector on the roof. I've had that solar collector and another one for 30 years,
Mhm.
right? And that's because heat pump water heaters didn't exist back then. But nowadays it's a mature product, okay? And if this one were to stop working, like tomorrow, I'd take it out and put it in a heat pump water heater because I've got the space to do it and I know how to vent them, and they're super efficient all year round. And they're cheaper than the solar thermal system.
Probably takes more area on the roof to collect enough electricity to run it.
No. The heat pump water heater just runs off of your house power, right? So, you just.
Well, I meant if you want to be solar.
Well, if you want to be solar, I would install that, okay, which has a very high coefficient of performance, right? It's giving you 3 times more energy than it's using in
Mhm.
terms of hot water, typically 3 to 5 times more energy.
Okay.
I would rather have a PV system on the roof than my solar thermal system. And
Right.
even 10 years ago, I would never have said that.
Right.
So, hey, Steve, are you
Yes,
are you there?
I'm here. Yes, barely just hanging in here. You won't believe we have the cell phone, my wife holding it way above her head, above the roof of the car, out the door.
Steve, yeah, I'm super impressed you pulled this off tonight. So the
Well, I
floor,
appreciate you coming. Thank you very much.
yeah,
I thank the other speakers as well. John Wheeler and Phyllis Garr, everybody was great. I see no more questions in chat. I wanted to put one more plug. We're going to have a really good speaker next meeting, which is July 21st. His name is David Green, and he has he's been giving talks around the state of Massachusetts. With their incentives, he gets 15% rate of return on his investment in Massachusetts for all the stuff he's done to go zero. And he's trying to convince everybody else in Massachusetts to do the same. So I've shipped him the New Jersey rebates and incentives, and he's promising to do the same sort of analysis for New Jersey. So we have him on the agenda for the third Thursday in July at 7 p.m. So I hope you join us then. You'll get an announcement separately.